Guys, so we're going to go ahead and start on section 1, topic 4, and this topic is dealing with the associative and commutative properties and a little bit of distributive properties. So one of the problems I want to go over is number 4. So it wants us to identify what's happening in each step, which property. So if you look at the steps from our original problem, 4 plus 7 quantity times n squared plus n squared quantity, and you look how it changes in step number 2. So they're separating the 4 and the 7 to both of those expressions in the parentheses. So I would consider this distributive property. And then in the third step, they actually go through and distribute. So I'm going to say that that's, I know that I can't spell, butive. And then if we look at the change from step 3 to step 4, it looks like all that happened was the 7m squared and the 4n squared switched places. And anytime terms switch in multiplication or addition, that is the commutative property. And then the last one there, just combining like terms. It's not necessarily one of those 3 properties. Okay, another problem I want to look at, just because the term analogy is just a little confusing. So you're going to use the diagram and the abbreviations to kind of show what's happening in this flow chart at the bottom. So if we look here, we're going from 2 times PQ plus XY, and then we change it to QP plus XY. So the Q and the P switch places. So that tells us commutative property, but these two are separated into commutative property of addition and commutative property of multiplication. We want to look at what's happening between the P and the Q. The P and the Q are being multiplied, so we're going to say that this CX is going to be what's happening there. And if we look from the second step to the third step, it looks like the same thing happened. The X and the Y changed place to YX, so we're also going to call that CX because that stands for the commutative property of multiplication. If we look from here to here, they switched the YX and the QP switched order. That is also the commutative property, but this time it's the commutative property of addition, not multiplication, because those two terms were being added together. And then from step number 4 to step number 5, it looks like they took the 2 and distributed it to both. So we're going to label that the distributive property. And then the last one, it looks like they switched, or they changed the parentheses around both terms. So we're going to say that that's the associative property, and specifically the associative property of multiplication, because they put the parentheses around the things that were being multiplied together. All right, and then the last problem I want to look at is number 8. So it says a times b squared and a squared plus b squared. Are these two equivalent? And which properties could you use to prove or disprove equivalency? So I would, obviously they're not equivalent. We've talked about squares before. And I don't necessarily know that I would use a property to prove this. You could. Neither associative or commutative properties would help us prove this. But one way that I would prove it is to provide a counterexample. So if I provide a counterexample, let's say that A equals 3 and B equals 4. So if I look at that first problem and I substitute 3 times 4 squared. 4 squared is 16. 16 times 3 would be 48. So that first one would be 48. If I use those same numbers, I should also get 48 if these two things were equivalent. So 3 squared times 4 squared, 9 times 16, which I could go through and calculate, but I know that 9 times 16 is not going to be the same thing as 16 times 3. So they are not equivalent. That would be the way that I would disprove equivalency, but you could also show that using the associative or commutative properties is not going to give you the same thing. All right, again, let me know on Remind or email if you have any other questions.